Stop doing random DSA problems. This will never gonna help you. Okay, if you are preparing for product based companies, this video will give you the complete list of data structure, algorithm, coding patterns, and more importantly what actually matters in interview. By the end of this video, you will know exactly what to study and what to skip. Structure is how data is stored so that we can retrieve it fast, and the storage will take the less space. Algorithms are how data is processed. So if you see in every real system, even if it is payment, search, notification, caching, even if database is storing, indexing, it uses some kind of data structure. Okay, everything is built using DSA. So never ever skip the DSA even if you are senior. Even 10-year-old senior person, if in system design interview, if you want to design any system, like how Uber finds the nearest driver, you need to know some kind of algorithms. Okay, the interviewer company don't test the syntax, they test the problem solving, how you optimize the code, and edge case thinking. Okay, so today we are not going into the depth of any data structure, we are going into the DSA roadmap. So let's start the complete list. Okay, so the first is primitive data structures. Okay, in primitive data structure we have integer, float, characters, boolean, pointer. So interviewer will not directly ask you to design these or what is the use of integer, float, character, but you must know what is integer, what is the size of integer, what is the minimum maximum value of integer, and how much data it can store. So there is always a limit. So likewise character, boolean, how to use the pointers. So always go and understand the primitive data structures. Then we have a linear data structure. In linear data structure, where we store the data in sequence. Okay, so for example array stores element in continuous memory. Why it is so? It is useful for faster access but fixed size. Then we have a string is used for text processing, pattern matching. Then we have linked list. So linked list, when we need a dynamic memory allocation, we go for linked list. So there is singly linked list, doubly linked list. So we need to understand how linked list works. Then stack works with last in first out, and stack is used in undo operations like parenthesis validation. There are certain problems on the stack which can be asked in interview. So queue works on FIFO, first in first out. This is used in messaging queues, task processing, used in scheduling. So from interview point of view, focus on stack and queue problems which are very common. Then we have hash based data structure. So this is must know topic. The hash map or hash set, which uses time complexity of O1 to store or to retrieve data. Okay, these are used for frequency counting in program, or fast lookup, or deduplication, caching. And let's say if you are weak, if you don't know hash map or hash set and how it works, then you will struggle in interview a lot. Most problems becomes easy when you use hashing correctly. Okay, then we have tree data structure. The tree is used for representing hierarchical data. In tree, we have binary tree, binary search tree, heap with min heap and max heap, then tria, segment trees. For example, heap is used for most common problems like top key problems. Tria used for string search. And from interview point of view, focus on how tree traversal works, heap and binary search tree validation. Then we have graph data structure. In graph data structure, graph and tree, it looks similar, but tree is used for hierarchical data, and graph, there are certain nodes which represent the relationships. In graph, there are types like directed graph, undirected graph, weighted graph, unweighted graph, cyclic graph, acyclic graph, directed acyclic graph. So learn what are the different types of graphs. Graphs are used in dependency resolution, network routing, social networking. Most graph problems uses BFS or DFS. Then we have advanced data structure. So advanced data structure, we might have a bigger list. So always start with LRU cache, how it is designed, then disjoint sets, Bloom filters, skip list. Okay, so there are many more advanced data structure problems. So always first learn all these data structures, then every problem solving will be easier. So in next part of the video, we will discuss the different kind of algorithms that we need to walk through at least once to know how these algorithms works. The first is sorting algorithm. Okay, in sorting algorithm, we have bubble sort, selection sort, insertion sort, merge sort, quick sort, heap sort. Okay, and these sorting algorithms have different time and space complexities. They are differently implemented. So understand it, where to use which sort. Okay, so mostly in our applications, we use the merge sort behind the scene, which has time complexity of year log year. Understand the merge sort and quick sort. You don't need to memorize all. Searching algorithm. In searching algorithm, we have linear search and binary search. So binary search is not just for searching, but it is used for other solving other scenarios too. Then we have recursion and backtracking. Okay, so this recursion means function calling itself, and backtracking is used for permutations, combinations, n queens problems, sudoku problems, and whatnot. So next is dynamic programming. The best thing of dynamic programming is most dynamic programming problems follow the fixed pattern. Dynamic programming is used when problem have overlapping subproblems. For example, Fibonacci, knapsack, coin change, longest common subsequence or longest increasing subsequence. Next we have graph algorithm. We have graph algorithm. In graph algorithm, as we discussed, BFS and DFS. Then we have Dijkstra's algorithm, then topological sort, union find, and these graph algorithms are used for shortest path finding and cycle detection or dependency order. See, string algorithms mostly used for search systems. Okay, so it has KMP algorithm. Then we have a Rabin Karp algorithm. And then there is TIA based search. Okay. greedy algorithms. Okay. So greedy algorithms to make the best choice at every step. For example, interval scheduling, activity selection, and there is Huffman coding. In these algorithms, it will be very useful from interview point of. Companies don't ask algorithms; they ask patterns. So must know patterns are sliding window pattern. Second is two pointers. Two pointers. Then we have binary search pattern. Binary search pattern. Then we have prefix sum. Then we have stack pattern. Stack pattern. Then we have heap top k pattern. Heap top k. Then BFS, BFS and DFS, dynamic programming pattern. If you learn this pattern, you can solve any unseen problems. So the most important thing, what to skip. Now listen carefully. Don't memorize rare algorithms. Don't solve random problems without patterns, and don't try to learn everything because DSA is about depth, not breadth.